Well, thank you so much, Egon, and thank you everybody for being here today. I have to say I was blown away when I got here about a half hour early for the presentation, and I almost couldn't find a seat because everybody here was earlier than me, so I appreciate your enthusiasm. As Egon mentioned, there are many, many scientists around the world and a great deal of scientific information that assert that we are not facing a climate crisis. It's very powerful evidence, and I'm going to present some of this here for you today. You probably have not seen much of this because it's hard to find sometimes. Hopefully it won't be hard to find in the future. Now, the first thing I want you to remember, if there's only one thing you remember from my talk today, I want it to be this. We cannot have a climate crisis when global temperatures are unusually cold. Remember that, because the whole asserted premise of the climate crisis is because of carbon dioxide primarily and other greenhouse gases. Temperatures are higher than they've ever been in history. The Earth has a fever and can't keep up. But all of that goes away when temperatures are unusually cold. Why do I say that? Because temperatures are unusually cold. That is what I want you to remember. This chart that you're looking at, this is data presented by the European Science Foundation. These are temperature measurements from the Greenland Ice Core project. Again, this is a source. Throughout my presentation, check my sources. I'm not just giving opinions or speculation. I'm giving actual data or information from publications, peer-reviewed journals. Right here, you're looking at the temperature history going back on the top left over the past 100,000 years. You see the last ice age glaciation where temperatures kept falling and falling. And ice sheets extended not only in the polar regions, but covering all of Canada, covering parts of the United States, covering much of Northern Europe. Then, about 20,000 years ago, you see a dramatic increase in temperatures when we finally escaped that ice age. On the top right, that chart is temperatures over the past 10,000 years. On the far right, you see the temperatures of today. Do you see that tiny squiggly line at the very far right that goes up just a little bit? That is all of the warming of the past 150 years. That is the warming that we are told to panic about. We are still far below temperatures that predominated throughout most of the time period that human civilization has existed. Human civilization began about 6,000 years ago. On this chart, you can see that's at the plateau, the very high temperatures. Those are temperatures that gave birth to civilization. We would have to keep rising temperatures at our present pace for at least 2 or 3 centuries before we reach the temperatures that have been normal throughout most of the time period that human civilization has existed. The bottom graph, those are temperatures over the past 2,000 years. Again, on the far right, that little increase in temperatures at the end, that is all of the warming of the past 150 years. Notice how during the medieval warm period 1,000 years ago, temperatures were significantly warmer than today. Indeed, when we do see some melting in Greenland right now, because temperatures are warming some. Over the past 100 years, we have a little bit of warming. When the ice recedes, what they find is villages and pastures from the Vikings who settled the area when it actually was green. Temperatures have been warmer than today throughout most of the time period that human civilization has existed. We cannot have a climate crisis when temperatures are unusually cold. Now let's move on to some other points that are very important here. Well, before we could do that, I want to show you this chart. This is cut and pasted directly from the United Nations Intergovernmental Panel on Climate Change's very first climate assessment report. It confirms the data that I presented in the last slide. Even the United Nations, you see in the middle chart, at the very far right, the United Nations confirms that very little bit of temperature increase in the past 150 years, that's all we've had. According to the United Nations itself, temperatures remain unusually cold, not warm. By the way, this is very interesting data. Scientists in the peer-reviewed journal Geophysical Research Letters, they published a history of the varying output of the sun's energy. The sun does not produce the same amount of energy all the time. It varies. It goes up and down sometimes. So scientists were able to reconstruct, going back to the year 1600, how much energy output, translate that to heat here on Earth, the sun has put out. What you see is that during the 1600s, that's when solar output was at a minimum. You had a step increase in the 1700s, then you had a plateau, and then you had a step increase in the 1900s. I want you to remember that pattern. Bottoming out in the 1700s, step up, plateau, step up in 1900. Does that look familiar? Look at the bottom chart here. This is the United Nations temperature history. When did temperatures bottom out? In the 1600s. They stepped up around 1700, they plateaued, and then around 1900 or so, we had an increase in temperatures. The sun has always been the primary driver of temperatures. When I say always, when you're looking at centuries patterns. If you go back hundreds of thousands or millions of years, you can look at the movement of the tectonic plates of the Earth's orbital precession. But for the time period that we're talking about now, over the last several hundred years, it's been the solar output that determines temperatures. Now look, carbon dioxide is a greenhouse gas. If you add some to the atmosphere, you should get some warming. But that's more on the margins. It's the sun's output that has always been the predominant driver of temperatures and continues to be so, as we see in this chart. Now here we have, this is an article, this is a graph that is looking back at carbon dioxide levels, temperatures as well, but I think the important thing is the carbon dioxide levels in the Earth's temperature history, going back hundreds of millions of years ago. The black line is carbon dioxide levels in the Earth's history. At the far right is where we are today. The Earth's atmosphere is starved of carbon dioxide. Before the Industrial Revolution, when we had parts per million in the 200s, we were getting perilously close to not having enough carbon dioxide in the atmosphere for life on Earth to even exist. If you get down to the mid-100s, plant life cannot engage in photosynthesis. All life dies. Throughout Earth's history, what we're looking at typically is we're looking at thousands of parts per million of carbon dioxide in the atmosphere. With the increase in the last couple of centuries, we're at a little over 400. Again, we still have an unusually low amount of carbon dioxide, not too much. Now, much has been made about the asserted connection between carbon dioxide levels and temperature. And yes, there is a correlation between the two. But the correlation is often presented backwards. If you look at the chart closely, and this again has been confirmed in the peer-reviewed literature, this was a chart produced in Chemical and Engineering News with an article describing the process. What happens is that temperature changes historically have always preceded changes in carbon dioxide. When there is a warming of the planet, for whatever reason, then you have more carbon dioxide released from the oceans. It's like if I open up a can of Coca-Cola. On a warm day, it's going to go flatter more quickly than on a cold day. It emits its carbon dioxide more. When it's colder, then you don't have the emission of CO2 from the oceans. Again, carbon dioxide is a greenhouse gas, but it factors in the margins. What we see is that temperature changes have always preceded the carbon dioxide changes. The causation is often presented in a reverse manner. Now, many times we hear in the news media and elsewhere, we are presented with so-called proof or evidence of a climate crisis based upon computer models. Computer models are not scientific proof. They're not even scientific evidence. They're informed speculation, which oftentimes prove wrong. So, for example, here we have all these squiggly lines. These are the United Nations computer models that they rely on to predict and project temperature change. The solid red line is the average of all those computer models. The green line represents observed temperatures, real-world temperatures. And what you see is that in the real world, temperatures have increased only about half the pace of the computer models. Doesn't mean we completely throw out computer models and never look at them? No. But it means we should take computer models, whether it's temperature or anything else, with a grain of salt, because they often do fail. In this case, they failed dramatically. By a factor of 2, they have over-projected the pace of warming, which is actually at a quite minimal pace. We're at a pace right now at about 1.4 degrees Celsius of warming per century. We'd have to warm at that pace, as I mentioned earlier, for 2 or 3 centuries to reach the temperatures that predominated for most of human civilization. Now, in the United States, the National Oceanic and Atmospheric Administration, they have a number of temperature stations from which they measure temperature and then report the official results. In 2005, they implemented their far and away most accurate temperature network. It's called the Climate Reference Network. And here we see the readings. Going back on the far left are temperatures in January 2005. On the far right, we have temperatures today. Yeah, we're having a little modest global warming, but if you see anything in the news claiming some catastrophic impacts in the United States, Well, they can't be talking about any time in the last couple of decades because we have had absolutely no warming whatsoever throughout the United States for at least the past 20 years. It's right there in the National Oceanic and Atmospheric Administration's data. Now, some of the assumed crises that global warming, climate change are causing, if you take a look at the actual data, we find no worsening trends. Look, the Earth's a big place. The Earth has always had hurricanes, tornadoes, wildfires, drought. Global warming, climate change isn't going to end that. It would be nice if it could, but it's not going to. So when we look at any relation between climate change and these extreme weather events, then we look at the frequency and severity of any trends during our modestly warming world. So here we have data. This is presented by meteorologist Ryan Maui using National Oceanic and Atmospheric Administration data. We look at the frequency of hurricanes throughout the world going back to the year 1980. On top, you have all hurricanes. On the bottom, you have major hurricanes. What you see is no discernible trend. When we are told in the media that climate change made this hurricane worse and made it more likely to happen, it simply defies the actual factual data because they're not getting any worse. They're certainly not getting any more frequent. Now, some of you may say, okay, well, that only goes back to 1980. We're talking maybe 40 years. Is that really enough time to make a conclusion? Well, certainly we don't see information backing up the assertion that climate change is causing hurricanes to get worse. But yeah, let's look back further in time if we can, because temperatures have been warming for past 150 years plus. So what you have here, these are graphics that were published in the peer-reviewed science journal Nature, and scientists went back and examined hurricane activity going back into the 1800s, the mid-1800s. So the top left is the one that matters the most. This is the global analysis of tropical storms and hurricanes. And what you see is that from the far left in the 1850s until today on the far right, you see a dramatic decline in hurricane activity. So the chart I showed you previously was from 1980 or so on. If you go back even further, the decline in hurricane activity is even more prominent and striking. Again, this is as temperatures are modestly warming. When a hurricane next forms in the Gulf of Mexico, if it comes here to Florida or Louisiana or somewhere else, and the assertion is climate change made it more likely to happen, no, we know for a fact that's not the case. Here are some recent hurricane facts, especially here in Florida, because hurricanes are a way of life. First, the United States recently went more than a decade without a major hurricane, category 3 or higher. That is the longest period in recorded history. If climate change is making hurricanes so much worse, why did we just have a record for lack of major hurricanes? It's not just major hurricanes. The United States recently experienced the fewest number of hurricanes of any size in any 8-year period. Again, if climate change is making hurricanes more likely, why aren't we seeing that? Florida recently concluded an 11-year period without a single landfalling hurricane of any size. That was the longest such period in recorded history. The Gulf of Mexico recently recorded its longest hurricane-free period in recorded history. And going back to Florida specifically, Florida recently underwent an 11-year period without a major hurricane strike, which again is the longest such hurricane in recorded history. I'm going to tell you a little anecdote here. This is funny. When that streak finally came to an end in 2017, and I would tell people before that, someday a hurricane's going to strike Florida. I mean, we're not going to go forever without hurricanes. And someday it'll be a major hurricane. And you watch, even though, by the way, this record for lack of major hurricanes essentially doubled the longest period before it. It didn't just break a record, it blew it away. And I would tell people in talks like this, I say, you wait and see. The first time we get a hurricane, they're going to blame it on climate change. People are going to call me up and say, still don't believe in climate change? So shortly after that, the hurricane struck, what was the hurricane? 2017, went up the Panhandle, went into Georgia. I forget the name of it. But a crew from the Weather Channel, they contacted me and they said, we see that you live in Florida and we're going to be in the Tallahassee area. We'd like to interview you on climate change. Are you willing to do that? I said, sure. I didn't have any more information what they're going to talk about. So they pick me up in a car and then they drive me through the Panhandle and up into Georgia, and they're pointing out all the devastation from the hurricane. And it was devastating. I mean, hurricanes are tragic, especially major hurricanes. And then came the gotcha question. Still don't believe in climate change? This is the first one in 11 years, the longest period in history without one. When you see that in the news, remember, anecdotes do not make a trend. They do not mean causation. They do not mean we're facing a climate crisis. Hurricanes will still happen, unfortunately, but they will. Tornadoes. We're in tornado season in the Midwest right now. This is a chart cut and pasted from the National Oceanic and Atmospheric Administration's own website. I didn't make it up. I didn't create it. What you're looking at, F3 or stronger tornadoes, the ones that kill people, the ones that destroy towns. What you see is that from on the far left, the 1970s, to the far right today, you see a dramatic decline in tornadoes. Climate change is not making them worse. If anything, it's making them less frequent and severe. Drought is another one we hear a lot about. Warmer temperatures, we're going to have more drought. This is a chart cut and pasted directly from the National Oceanic and Atmospheric Administration's own website, their own data. What you see is on the green, okay, on the far left, you're looking at 1895. Every bar is a month from then until now on the far right. The green is the percentage of the country that NOAA, the National Oceanic and Atmospheric Administration, defines as having very wet conditions. And what you see is essentially no trend. If anything, a little more wet recently, but not much of a change. But look at the yellow bars going down towards the bottom. That's the percentage of the country undergoing very dry conditions. And then they break it down. You see 20% of the country, 40%, 60%. At the very bottom of the chart is 80%. Notice how that from the 1890s until about 1960, on a very regular basis, more than 40% of the country was experiencing very dry conditions. It happened on a regular basis several times per decade. Since then, notice how it has been several decades since even once 40% of the country has been experiencing very dry conditions. This is the longest period in recorded history, going back over 100 years, without at least 40% of the country experiencing drought. When there is drought in some place of the country, because the country is a big place, we always have it, the media will play it up like California or New Mexico, wherever it happens to be in a given day, how horrible it is, and climate change. Experts, scientists say climate change is to blame. No, the actual data says not even close. Droughts are becoming less frequent and less severe as our planet modestly warms. The reason for that is you have more evaporation over the oceans. That air then comes over to land masses and you get more precipitation. Here on the right, that's a NOAA chart from 1895 to 2020. The very few areas of yellow and red, that's where we've had less rainfall in the period since 1895, a declining trend. The green is where we see increasing amounts of rainfall as time goes by. As our climate warms, we're getting more precipitation, not less. On the left, there are two instances that I've highlighted. In April 2017, the United States recorded the fewest miles, acres of land experiencing drought ever recorded. National Oceanic and Atmospheric Administration. We've never had this little drought in our country, ever. 2019, we broke that record. Even less of the country was experiencing drought. So again, when you see that their drought is occurring, as they will occur, there was even some places of drought in 2017 and 2019, don't believe the media when they say climate change is to blame. We're getting less drought as temperatures modestly warm. Wildfires. Wildfires are a big one in the last few years in the media, where wherever there's a wildfire, they say, well, climate change is making conditions hot and drier, and that's causing wildfires. Well, we know it's not making conditions drier. I just showed you that. But let's look at the actual data on wildfires. On the right, that is an image I cut and pasted from NASA's website. Their information, their image, not mine. The areas in red show where there's been an increase in wildfires. The blue areas are where there's been a noticeable decrease in wildfires. NASA satellites have been measuring precisely with satellites the amount of land globally burned by wildfires since 1998. NASA reports there has been a 24% decrease in wildfires since 1998. The world is a big place. There will be dry conditions, there will be wildfires in various places. But just because wildfires still occur doesn't mean global warming is causing them. As our climate has modestly warmed, we see a decrease in wildfires, not an increase. And in fact, again, you may say, okay, that's going back to 1998. You're only talking about 25 years. What about before then? What do we know about that? Okay, we didn't have the satellites, the precise satellites that NASA has. We didn't have that before 1998. But scientists in Journal of Geophysical Research, peer-reviewed science journal, they went back to the year 1900 and analyzed through the records what wildfire trends had been. What they found is that from 1901 to 2007, there was a, quote, notable declining rate of burned area globally. As temperatures have modestly warmed over the past century, wildfires have become less frequent and less severe. Here in Florida, Florida is pretty typical when you look at temperatures throughout the country. If you go back to the past 100, 150 years, yes, temperatures have warmed a little bit, as I showed you earlier. The same is true in Florida. But is it causing heat waves? Is it causing the extreme temperature indexes that some models and people predict? Well, here we have the actual data. This is cut and pasted from the National Oceanic and Atmospheric Administration's own website, their chart, their data. This is the number of days with a maximum temperature of 95 degrees or higher in Florida. As they put it, Florida, very hot days. What you see is, at worst, no trend, although really what we see is a declining trend. So how is it that we're getting a little bit of warming in Florida? It's occurring in Florida as it's occurring in almost every other state in the country. We have an increase in temperatures at nighttime. Not the hot spells, not the heat waves, not the middle of the day. And especially during the winter months, winter nights. So yeah, we're getting a little bit of warming, but we're not getting all of these heat waves and record-breaking temperatures. In fact, they're becoming less likely over the past, here you're looking at 100 plus years. Now, from the National Oceanic Atmospheric Administration, same website, they're looking at precipitation. What you see is essentially no trend. Now, in Florida, there will occasionally be droughts. I mean, I've lived here since 1994. I had to recently move to Chicago. Believe me, I'm coming back soon. But I've driven through areas of drought. I've driven through wildfires when I got near Gainesville, where the whole sky was clouded with smoke. These things happen. They're terrible events, but they're not getting any more frequent or severe as our climate warms. Again, if anything, just the opposite. Now, we hear a lot about the supposed extreme weather impacts and all these horrible harms that are coming as a result of climate change. I hope I've showed you that that's not the case in the real world. I presented actual data. I presented peer-reviewed scientific studies. It's data that changed my mind. 20, 30 years ago, I set out to write an article for my student newspaper at Syracuse University, hoping to convince my fellow conservatives, libertarians, that look, I believe in a limited government too, but if we're burning up the planet, we got to do something. But the more I looked at the data, I mean, I'd studied atmospheric science when I was at Dartmouth as an undergrad. The more I looked at the data and saw stuff like this, of course, earlier time period, the more convinced me that we're not facing that climate crisis. Yeah, temperatures are rising, but the assertions of all these harms that are resulting just aren't happening. Now, that's just one part of the equation. Another part of the equation that never gets reported, it's not just that we're not getting all of the negative impacts from climate change. It's that we're getting a significant amount of very meaningful and powerful benefits that are never reported. So here's one that I mentioned. If there's one thing you remember, you can't have a climate crisis when temperatures are unusually cold. We're unusually cold. Here's the second one, the second most important one, I think. This is the number of people who die around the world as a result of cold rather than heat. This is data published by The Lancet, probably the world's leading peer-reviewed medical science journal. Scientists examined mortality rates, deaths from people all around the world. What they found was that approximately, I think it was 7.78% of deaths globally can be attributed to temperatures that were not optimal, temperatures that were harmful. When you break that down, that's nearly 5 million deaths every year from temperatures that are not optimal. But here's the kicker. What you see, now here you have representative countries in the study, Australia, Brazil, Canada, USA, China, etc. The dark blue bars, that's the number of people who died because of extreme cold. The light blue bars, the number of people who died because of moderate, persistent cold. The light red or pink, that's the number of people who died from moderate, persistent heat. And in red, the number of people who died from extreme heat. What this study found was that approximately 20 times more people die from cold rather than heat. When there's a heat wave, oftentimes in the media we'll hear about how climate change is causing more heat-related deaths. Well, it'd have to cause about 20 times more heat-related deaths to get to the number of cold deaths. As our climate modestly warms, what we're doing is we're saving lives by the millions. Those blue bars, especially the light blue bars, from persistent cold, those become less and less frequent and less numerous. Those are real people, real lives, real deaths that are occurring right now. As our climate modestly warms, we will be saving, and already are saving, lives around the globe in just enormous numbers. Here's another one we don't hear about in the media. In fact, we get misinformation just to the opposite. Oftentimes, it'll be asserted if there's a drought somewhere, again, there's less drought than there used to be, but that, well, this is just more evidence of how climate change is making it harder for farmers to produce food. The food output is falling. We have a food crisis, or soon we'll be having one because of climate change. This chart is cut and pasted directly from the United Nations Food and Agriculture Organization's website. What you see, this is their 10-year chart. On the far left is 2013-14 growing season. On the far right is what we have today. What you see is a significant increase almost every year in the amount. This is cereal production. These are the big three: corn, wheat, and rice, the ones that matter most. What you see is that almost every year a new record is set for crop production. By the way, we could make this a 20-year chart, 30-year chart. It's the same thing. The same trend all over the world. And not just the world in aggregate, but in almost every single country in the world, you have the same results, where records are being set on an almost annual basis. If the assertion is that climate change is causing crop failure, where is it in the data? Here's what climate change is creating: more rainfall, as we saw, longer growing seasons, fewer frost events, and carbon dioxide is itself plant food. That's why horticulturists pump CO2 into greenhouses. And one other note, a greening of the earth. Scientists, NASA satellites, this is an image from NASA's own website. What they did is they measured from 1982, they were able to measure the amount of foliage, vegetation around the earth. And what scientists notice is that there has been a substantial greening of the earth, an increase in foliage and vegetation, going back at least since 1982. And NASA ascribes it specifically to an increase in carbon dioxide in the atmosphere. A greening of the earth is a wonderful thing. This is good not just for humans in terms of crop production, but for ecosystems throughout the world. You don't hear that much in the news. You have all this good news from more carbon dioxide and warmer temperatures. We don't hear it much, but you're hearing it today. Now, Professor Wanless talked about sea level rise. If there's one issue I think that deserves a little more consideration than others, it is sea level rise. So I'm going to address that in just a moment. But before that, it's important to understand, if you do believe, despite the information I just showed you, that we're facing a climate crisis, or perhaps could be, and we want to do something about it, there are two things to do. On a personal level, you can sell your Naples Beach home if you're fortunate enough to have one. And on a larger scale, you can send delegations to China to petition them to reduce their emissions. Because the fact of the matter is, the United States, since the year 2000, has decreased its carbon dioxide emissions more than any other country in the world. More than any other country in the world. US emissions are down 21%. Now compare that to the rest of the United Nations. Their emissions are up 47%. And the vast majority of that is due to a single nation, China. Here on this chart, you see carbon dioxide emissions going back to the year 2000. The United States, that's the blue line that's going down. The gray line is China. The orange line is the rest of the United Nations as a whole. If I wanted to reduce carbon dioxide emissions, if I thought a climate crisis was coming, I'd want to go to where the source of the problem is, because we can keep reducing emissions all we want, and global emissions still rise. That's what they're doing. When I flew down here today for this meeting, again, I'll be back here soon. I can't wait to move back to Florida. But if I got here and I got to the airport and I went to look for my keys and I saw they weren't there, and I said, oh, wait a second. I put them down next to me at the coffee counter in the Chicago airport. I'm not going to go looking for my keys all around the Tampa airport or the Naples airport. I'm going to go to Chicago and look for them. That's where the problem is. If we want to reduce carbon dioxide emissions, if we think there's a problem, that's what we have to do. We can talk about the issue. If you think that there's other information that shows we are facing a crisis, if we're not getting China to go along, it does not matter a whit what we do here in the United States. Indeed, we have been reducing emissions, and yet we still have the increasing emissions. If the rest of the world would follow our lead, even if I'm wrong, even if the data I showed is off, still we don't have to worry about any of the future forecast problems, because carbon dioxide emissions globally would be going down. All right, sea level. Now, whether people talk about hurricanes, tornadoes, drought, I mean, all of these topics, the evidence is overwhelmingly against the notion of any worsening or any increasing frequency due to climate change. Sea level rise is the one issue, and for Professor Wanless's presentation this morning, it's very informative. And it's the one topic that if I were going to be discussing and say this is a concern to look out for, it would be sea level rise. If temperatures are warming, regardless of the blame, regardless of the pace, you're going to get some sea level rise. So the question is, though, are we getting sea level rise? Well, there's a few questions. What's the cause? How much can we expect? What would be the effects? So here's an overview of sea level rise. Right now, we're experiencing sea level rise of approximately 1 foot per century. And I'll show you the actual data shortly. 1 foot per century. It's not 2, 3 feet, not 4 feet, not 8 feet. There'd have to be a dramatic rise in the pace, a dramatic acceleration to have any of the harms of 8 foot or 4 feet of sea level rise or whatever we see on the maps when we look at them. We're getting a pace of 1 foot per century. That's it. By the way, that's a pace that's essentially been the same since the mid-1800s. People have adjusted to it quite well with technologies available in the 1800s, 1900s, here in the 2000s. Again, it's not saying it's not going to cause any challenges, but we've been successfully mitigating that and managing it for quite some time. We don't have a crisis right now. We're unlikely to have one anytime in the foreseeable future. For any of the fears of a rapidly disintegrating, whether it be Antarctica or Greenland or anything else that would cause an acceleration, because if you're looking at the major harms of 4 foot, 6 feet, 8 feet, 10 feet, 20 foot sea level rise, you have to have a disintegration of the Antarctic or Greenland ice sheets. I'll get into it a little bit more. But what's interesting, remember the temperature chart that I showed. The most important thing to remember, temperatures were substantially higher for a period of at least 4,000 years. The Antarctic ice sheet did not melt then. The Greenland ice sheet did not melt then. What would be different that it would melt now when temperatures are significantly lower? If temperatures were 2 to 3 degrees Celsius warmer for an extended period of 4,000 years and more, it stands to reason that now when temperatures are much lower, that we're not facing an imminent melting of those ice sheets. And also, sometimes when we see in the media reports of what could happen with 10 feet of sea level rise or whatever else, even the United Nations Intergovernmental Panel on Climate Change, which tends to overstate their predictions. You saw it in their temperature predictions. They predicted twice as much warming has occurred. The IPCC's midpoint expectation of of sea level rise this century is 2 feet. Well, we see in the records it's really 1 foot. That's what's most likely going to happen. But even 2 feet is something that's far different from 4, 6, 8, 10, 20 feet. All right, here, this graph is taken from the University of Colorado. They have a program where they chart sea level rise. They're using NOAA instruments on NASA satellites. On the left in the chart, you see the various iterations of those satellites, the JASON 3, JASON 2, JASON 1, and TOPAX data. It goes back to 1993. And what NASA reports, or NOAA, they're both reporting it, is that we're seeing 3.5 millimeters increase in the volume of the oceans per year. Now, the volume of the oceans, they have to adjust for isostatic adjustments. What the sea level rise is approximately 3.2 millimeters per year. That's 12.94 inches of sea level rise per century. That's our present pace. That's what's reported by NASA and NOAA. By the way, when we look at, you can say, okay, that's 1993. How does that relate to time periods past? Well, actually, I'll get to that in a moment. Here's a chart where you look at, on the left, you see the NASA chart. On the right, you'd see on the bottom from 1993 until 2024, you see the data that they've reported. That's the pace of warming that we've experienced. And by the way, it's pretty much a straight line. There's no acceleration, or very little, if any. Then you see the acceleration that we would need to get to 8 feet of sea level rise this century. We need an 8-fold increase starting today. It's unlikely to occur. Predictions of that just simply are not likely to occur. That's good news, by the way. All right, so it's often asserted that, well, sea level has increased its pace starting in whether it's 1993 or whenever else. We have the absolute conclusive satellite data from 1993. It shows no acceleration. We do have tidal gauges that go back in various places. The longest one that's been in operation in the USA, which is also one of the longest in the world, is at Battery Park in New York. And here you have on the far left, you have the sea level beginning in the mid-1800s, 1855, up through today. It's essentially a straight line. There is no acceleration in the 1930s or the 1960s or the 1990s or anywhere else. We see the same trend that was shown in the previous slide from the precise satellite data. We do not see the acceleration that is sometimes claimed. All right, this is the sea level data from Miami at Virginia Key. This is from 1930. Again, you see essentially a straight line, a little bit of increase in the end, but there have been little bit of increases periodically throughout the record. Even if that little bit of increase held, you're still not looking at anywhere above 2 feet, so you're not even getting to that. But essentially a straight line. Here's St. Petersburg, my longtime home. Going back to 1945, again, essentially a straight line. This is Naples, going back to 1930, and again, essentially a straight line. You can make an argument that since 2010, there's been some increase. 10-year trend. We've had 10-year trends. You see it in 1980. You saw it before in about 1955. You saw it in 1945. Probably doesn't mean much. Even if it does, again, it's not a dramatic increase that you're looking at quadrupling or 8 times as much sea level rise as in the past. Going back to the Battery Park data, you see on the right, there's the long-term trend in sea level rise. And you'd see what would have to take place starting now to get to 8 feet sea level rise by the end of the century. Folks, it's just not going to happen. It's absent we have a sudden disintegration of Antarctica or the Greenland ice sheet, which did not happen when temperatures were much longer for extended periods of time. We're going to see essentially the same trend of a foot sea level rise per century, maybe a little bit more. So all of the things that we're told to fear for 8 feet, 10 feet, 20 feet of sea level rise, yeah, if it happens, that's pretty rough. It's just not happening. It's not going to happen. We know because temperatures were much longer for extended periods of time and it did not happen. So here's Greenland, for example, looking at the ice trends in Greenland. The yellow line you see going back to, it's about, 15, 20 years ago, I believe. Because on my screen it's small. You probably have a bigger view of it. But where you see it, you see pretty much the same pace of ice loss. You do not see any acceleration. And actually, I'm going to come over to the screen for a minute just because I want to illustrate this here. So this is starting in 2003. This is the ice loss. There's no rapid deceleration. Earlier, we were presented the data up to 2012. Now, this data I've been able to find this is through just a few months ago. So here's where the data we saw this morning ends. Here's the ice loss data since. We don't see an acceleration. In fact, we don't even see a continuation. We see less ice loss trend. The trend is decelerating, not accelerating. That's good news. Same thing for Antarctica. We see on the left, we see the Antarctic, the pace of ice loss going back to 2002 through today. What's interesting is that on the or through 2020, the latest that they reported the data. So what you see is you don't see an acceleration, you see pretty much a straight line, but as we see on the far right, you see that there has been, the far left was Greenland, the far right is Antarctica. And what you see is that from 2016 on, it's been pretty much flat. There's no acceleration. That's good news. If there's acceleration, then yes, let's get concerned, let's look into it. But there is not happening the acceleration that some people have predicted. All right, before wrapping up, some resources for you. If you haven't seen any of this data before and you'd like to find it on your own, there is a book that the Heartland Institute, my organization, has published. It's Climate at a Glance. We take 30 of the topics that are most frequently discussed in this topic: hurricanes, tornadoes, coral reefs, ocean currents, whatever it may be, and we present the facts. Just like here, my presentation, I presented facts, I presented data, and I presented peer-reviewed studies. So here we break it down 2 pages per topic, so it's quick, it's easy to read, it's concise, but it's informative. You can find that at climateataglance.com. You can order the print book on Amazon, Climate at a Glance, $10. You can get it for free at climateataglance.com. And on your cell phone, if you go to the App Store or whatever it is for Apple and Samsung, you can get the app for free. So do a search for Climate at a Glance and you'll have it on your cell phone. You just punch it up in 5 seconds. You have anything you want. You can have the chart I showed you, the most important thing to remember. You can have that at your fingertips in 5 seconds to show anybody who says, well, what about the fact that these were the 10 hottest years in history? No, they weren't. So anyway, I urge you to do that, and I hope that'll be a good resource for you. Also, we have a website, climaterealism.com. So Climate at a Glance is the topical information. Climaterealism.com. We go day by day. We do a Google News search. What's a hot climate topic of the day? If there's a wildfire in California and the media is saying it's due to climate change, we rebut it. We present the actual information. So whatever's hot in the news, if your friends, neighbors, spouse, children, parents are bringing it up, you can get the facts right there. So thank you so much, and I'm more than happy to take any questions you have.